Welcome in. Our objective for this video is to identify limiting reactants, theoretical yields, and percent yields. In our previous video, we introduced this idea that our chemical reactions are like recipes. They tell you the relative amounts of every starting material and product involved. When you're cooking and when you're doing chemical reactions, you're not always going to have the perfect amount of ingredients. Here's my recipe for the perfect pizza: half a pound of dough, half a cup of sauce, 3/4 of a cup of cheese to create one pizza. But what if you go into your kitchen and you only have 2 pounds of dough, 1.5 cups of sauce, and 6 cups of cheese? Well, we can definitely do our recipe at least once, but what is the most number of pizzas that we can make? To check, here's a strategy. We want to do some math. For each of our ingredients, let's calculate how much product we can make if we use all of that ingredient. It's hard to compare sauce to cheese to dough, but if we convert everything into number of pizzas, it's easy to compare pizzas to pizzas. Here's what that looks like. If we have 2 pounds of dough, we don't want pounds of dough, we want the number of pizzas. One pizza requires half a pound of dough. It looks like our dough is enough to make 4 total pizzas. For our sauce, we need to have 1/2 of a cup of sauce to create one of our pizzas. And so with our sauce, we can only make 3 pizzas. Well, we have enough sauce for 3 pizzas and enough dough for 4 pizzas. Can we actually make 4 pizzas? No, because we'll run out of that pizza sauce. You can't make the pizza, the perfect pizza, without exactly that much sauce. If we run the numbers for our cheese, we have enough cheese here to make 8 pizzas. But again, we run into this problem. We need to look for the smallest amount. Based on these ingredients that we're starting with, we don't have enough of our sauce to keep going after we make 3 of those pizzas. We get to draw 2 conclusions from these calculations. One is that our sauce is going to run out first. And 2 is that the maximum amount of pizzas we can make is 3, based on the thing that runs out, based on our sauce. We're going to call our sauce here the limiting ingredient, or the limiting reactant, the substance that runs out first. We're going to call the 3 pizzas that we can make our theoretical yield. The maximum amount of product that you can make has to be based on our limiting ingredient. This is a rule for our recipe and for our chemical reactions. You can only make as much products as your limiting reactant allows. Our limiting reactant is the one that runs out first, and the amount of product that we can make based on that limiting reactant is called our theoretical yield. Here is our strategy listed out. We want to do a conversion for each of our starting materials. Choose one product to convert to. Convert all of those starting materials to that same product in the same unit. Once we do that, now we can make our easy comparison. The smallest amount of product gets to be our theoretical yield, and the reactant that led to that product is our limiting reactant. We have a few straightforward examples here. If we have 1 mole of HCl and 0.8 moles of NaOH, we need to have them in a 1-to-1 ratio. And in this case, we don't. So based on what we can make, our 0.8 moles of sodium chloride is our theoretical yield, and our 0.8 moles of sodium hydroxide is our limiting reactant. If we start with 2.8 moles of HCl and 3.2 moles of NaOH, well, now we can see that our smallest amount of product is 2.8 moles of NaCl. That is our theoretical yield, which means this 2.8 moles of HCl has to be our limiting reactant. Now that we can calculate our theoretical yield, we can start to consider our actual yield and our percent yield. In the kitchen, we're not always going to end up with the maximum amount of things that we could make. Same in the lab. Sometimes we spill something. Sometimes one of our pizzas gets burnt. Maybe your dog jumps up and steals a slice of pizza, right? We're not always going to be able to produce exactly as much as we expect. In chemistry, we'll see later on in future chemistry classes, some reactions just aren't very efficient, can only ever get to 80% complete, or 90% complete, or 25% complete. So for many reasons, maybe our fault or maybe no one's fault, we're not always going to collect as much as we would like to. We can quantify this using the formula for percent yield. This formula relates the actual amount that you collect in the lab to the theoretical yield that you can calculate based on your starting materials. Take that ratio and multiply by 100%. Here's a quick example. If we theoretically could create 3 pizzas with what we have in our kitchen, but then our puppy comes in and eats half of one of those, we only actually end up with 2.5 instead of the 3 that we expected. Or in other words, we were able to eat 83% of the pizza that we would have expected to. Here's what one of these problems looks like in practice. We start with 4.8 grams of sodium, 2.6 grams of fluorine, and in the lab, we're able to collect 0.41 grams of our product. Our plan is to do a calculation for each of our chemicals in order to decide what is limiting. We can start by getting to moles. If you have 1 mole of sodium, how heavy is this? Turns out on the periodic table, we can see 23 grams for every 1 mole. We don't want to be thinking about sodium. We want to be thinking about how much of our product, right? So we can make that good, easy comparison. In our reaction, 2 sodiums are required to make 2 sodium fluorides. Lastly, we can convert instead of moles to grams of our product because that's what we're going to compare with eventually anyways. How heavy is 1 mole of sodium fluoride? Well, we can use the periodic table. If we consume all of our sodium, we'll end up with 8.76 or 8.8 grams of our product. we need to do another calculation for our other reactant. The first step, we want to convert into moles instead of grams. 1 mole of our F2 is worth 38 grams. Next, we'd like to convert to our product, again, so we can make that easy comparison. This time, our ratio is a little bit different. Using the reaction, 1 of our F2s can create 2 of our sodium fluorides. The last step here looks the same, converting from moles of sodium fluoride into grams sodium fluoride. What we see is that based on our F2, we can create 5.7 grams of our product. Check out those two numbers all the way on the right. Which one is smaller? That is going to be your theoretical yield. Yield always refers to a product. Whatever reactant led to that theoretical yield has to be our limiting reactant. Remember, a reactant is a starting material, so the limiting reactant has to be one of our starting materials. The last question here, we know that we actually collected 0.41 grams of our NAF when our best case scenario was making 5.7 grams. We end up with 7.2% yield. This reaction was not very efficient, maybe because of something we did in the lab, or maybe because of the limitations of this chemical reaction. We have a practice question for you, so grab your paper and pencil, try to figure out what that good answer has to be. And there we have it. We are able to identify our limiting reactants, our theoretical yields, and our percent yields. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.